Hi, this is Ed Blomdahl once again, and I'm here to talk about another video that I am making and some ideas that I have come up with. And so this is it. It probably takes about 40 minutes to get through all three, so to get through the whole, the three whiteboards. And let's begin. But before I do, I couldn't fit everything I wanted on the whiteboards, so what I did was have some cheat sheets here, so you'll have to forgive me if I revert back to the cheat sheets to enhance what I'm showing here on the board. So let me read this. So the title today is Thoughts on the Special Theory of Relativity and the General Theory of Relativity, Appearance versus Reality. So that's what I'm going to talk about mainly, the appearance versus reality, what you can use, what you can't use. So before I start, let me say this. As with all my other videos and papers, all ideas and conclusions presented in this video are mine and mine alone. I neither sought nor received any assistance from anyone at any time. No one does the work that I do because no one thinks that I do, like I do. And that's because they basically blocked everything that I come up with. So anyway, let's get into it. The entire special theory of relativity is based on something called the Lorentz Factor. And here it is right here, right, with a little, it's 1 over 1 over the square root of 1 minus VC squared. And it's sometimes denoted by gamma. So that really inhibits anything from going faster than the speed of light. Just the way that, and it was designed to do that. And in fact, but if you look at, you can get a copy of this, it's Einstein's 1912 manuscript on the special theory of relativity. And I believe that it's on page 82. Let's see if I got it here. I believe it's on page well, I had it written here. Oh, page 84. It's written on page 84 about, Mr. Einstein is saying this in his papers, that it's basically a hypothetical, and I agree with that, although he later added it in. Part of the situation is also that he came up with some thought experiments or whatnot to show, or came to the conclusion that nothing can travel faster than the speed of light. And one of the experiments was if he is flying at the speed of light and light comes in and hits his face, is it going to reflect back at twice the speed of light? And he said no, that wouldn't happen. But if you think about it, if you're traveling at any speed and the mirror, and you have a mirror in front of you, and well, go back to the speed of light, and speed of light hits the mirror, what's going to happen? If you say it doesn't reflect back, then you're saying basically the light just hits the mirror and just stays there, right? Completely inelastic collision. But I don't think that's true. In other words, if you're going to the speed of, if you're holding a mirror at the speed of light, a light beam comes at you, what's going to happen? It's going to reflect back. At what speed? Well, I'd say the full speed, because that's how it is on all the others. If you have a truck coming at 50 miles an hour and you throw a ball at 50 miles an hour against the truck, it's going to rebound off that truck. Now, whether it goes at 50 plus 50, 100 miles an hour back at you, depends on what the variables in the situation and how elastic or inelastic it is. And the same thing with the speed of light. I mean, it sounds odd that it would come back at that fast, maybe speed of light plus the speed of light, but your other choice is, it'll just hit the mirror and do nothing. So I think that was a problem with Mr. Einstein's thinking there. So, I came up, if you notice, I came up with a paper that's on YouTube, and it's the title is "Breaking the Light Barrier, Adding Velocities Beyond the Speed of Light," and that's exactly what it does. Because they compared it to a locomotive. If a locomotive is traveling and it sounds the horn or whatever, the sound is independent of the speed of the locomotive. But sound also travels at different speeds in different mediums. Water and fastest in steel, right? Quite a bit faster. So you have to take that into account. And the locomotive, what else was I going to do? Anyway, the speed barrier, and I show that you can add, in Maxwell never said that you can't add the speed of light with the motion of its source, right? That's Einstein's doing, to add that, but it's incorrect, and that's what the paper shows. So you can go look at that. So let me talk to you about the axiom that I came up with. And it's simply stated, it's simply because one can write an equation doesn't mean it has any relevance to reality. I call it Ed's axiom because I couldn't fit Blomdahl in there. But simply because one can write an equation doesn't mean it has any relevance to reality. And two good examples of this, as far as I'm concerned, are one, string theory, and two, Mr. Einstein's general theory, right? I said it to, I won't say who, but I said that both of those have the same problems. They're 90% math and 10% bad idea, right? I've also said that if the concept is correct, then the math will follow, right? The concept has to be correct, and then you can just draw up the math. The math, in some ways, although I know it gets complicated, is the easy part. Coming up exactly how that system works, the physics of it, and the signals and whatever else is involved in it, that's a different story, right? That, I think, is more difficult. So we have the Lorentz factor. The whole special theory of relativity is based upon it, and it's wrong. So when I go through my paper or the video, Breaking the Light Barrier, I basically state that's what exactly happened. The special theory of relativity has nothing to do with reality. Okay, and I'll go apart. So here's one, time dilation, right? We all know about time dilation. The equation's pretty easy. Gamma is just the Lorentz factor up here. You have relative time, you have the gamma fraction, and then you have the proper time. And you just put numbers in there, mostly v, right, the velocity, the relationship between v divided by c, and you can come up with a number. It has nothing to do with reality. Time is simply a concept, right? As such, it doesn't exist. So that's why you can't, in absolute time, not relative time like looking at your watch, in the universe, at some absolute time, it doesn't exist. Well, if the general theory has to go back, or the special theory has to go back, let me break from that. I'll do that later. So you can put numbers in there, but it won't work. Time, like I said, is a concept. A map is to lines of latitude and longitude what a watch or clock is to time. The map is real, but the lines of longitude and latitude aren't real. The clock and the watch is real, but time isn't real. It's a concept, right? Lines of latitude and longitude are concepts. They don't exist in reality. This is why you can't infuse time into either Minkowski's flat space, right, or Einstein's curved space, right? It doesn't work. It won't ever work. So again, just because you can write an equation doesn't mean it has anything to do with reality. And in this case, it has nothing to do with reality. how about the Lorentz factor? How about that Lorentz factor, huh? Oh, one thing about the twins, you know, time dilation and the twins. If one of the, you know, one twin is on Earth, the other goes into space, he's traveling near the speed of light, turns around, comes back, and he's, you know, 10 years younger than the twin that stayed on Earth. Okay, that's rubbish. If the twin in the craft going near the speed of light cannot use his mind to develop a experiment that would tell him decisively whether he were in motion or not, right? If you can't use the mind, then how is one's gallbladder going to know when it's time to slow down, right? Or a liver, or someone's toenail, or someone's hair, right? How is that going to happen? There's no signal coming to it, because then they'd figure out if they were in motion or not. So they're there by itself. You can't tell anything about it, and yet somehow magically, you know, people are going to age younger. Not true. Has nothing to do with reality. Okay, so let me go on to. Also for time dilation, I have a video called "The Time Is Up for Space-Time," which states that, you know, you can't infuse time, right, in the absolute sense into a three-dimensional space. So if you can't do that, if you can't infuse it, then, you know, you can't be the curved space-time of the general theory. It can't be the flat space-time of the special theory. All right. So time delayed. You have an action. It's just an appearance, right? It's an appearance, maybe, that somebody appears younger or something. It's not a reality. And you have to explain in words how the twins paradox actually works, and just writing an equation doesn't cover it. That's my point. The Lorentz factor. We know that if a object travels near the speed of light, it starts to contract in the direction of motion. That's what it supposedly does, right? And this is it right